Here is the video solution for the exam number 2 preparation problems for trigonometry. As an important note, you must use methods discussed in class lessons to solve the following problems. Notes are not allowed, and all work must be clearly shown. A non-graphing scientific calculator is okay. In the first group of problems, we are asked to find trig values of double and half angles with the following given information. Sine of theta is equal to -7/25, and theta belongs to quadrant 3. And we wish to find the exact value for all of the following. So let's go ahead and start with the cosine of theta over 2. There is an identity for this. Cosine of theta over 2 is plus or minus the square root of 1 plus the cosine of theta all over 2. Now, as an important note here, the plus or minus is a choice that you need to make based on where theta over 2 lies. So what we know about theta is that it is in the third quadrant. So that means that theta must be an angle between 180 degrees and 270 degrees. If we divide all of these numbers by 2, we can see that theta over 2 must be an angle between 90 degrees and 135 degrees. And this means that theta over 2 must be in the second quadrant. So now that we know that theta over 2 is in the second quadrant, in that second quadrant, cosine is a negative value. So we are going to choose negative. So from here, we know that the answer is going to be negative square root 1 plus cosine of theta over 2. So now the question is, what is the cosine of theta? Well, we were given information about sine of theta. Let's draw a picture of this. So again, theta is in the third quadrant. So it must look like this. And we know that sine of theta is -7/25. And I'm just using the fact that sine is opposite over hypotenuse here. Now, to find the cosine of this angle theta, we need to know how long this side is here. So let's go ahead and call that x, and then we know that x squared plus -7 squared must be equal to 25 squared. And this is x squared plus 49 must be equal to 625. Subtracting 49 from both sides, we get x squared is equal to 576. And then taking the square root of both sides, we see that x must be plus or minus 24. Now again, here, x is not plus or minus, it's one of the two. And since we are talking about an angle in the third quadrant, we know that both the x-coordinate and the y-coordinate should be negative. So we are going to conclude here that x must be -24. Now, once we know that, we can fill that in here. And we now know that cosine of theta is -24/25. So now to finish this problem, we know that this is going to equal negative square root 1 plus cosine of theta, which is -24/25, all divided by 2 there. Do the math here. 1 plus -24/25 is 1/25, and that's divided by 2. Now again, what I'm doing there basically is I'm changing 1 to be 25/25, and when I subtract 24/25, I get 1/25. So that's the work that I'm doing to do this part. Now 1/25 divided by 2 is the same as 1/25 times 1/2, and that is 1/50. So what we have here is negative square root of 1 over 50. And from there, we're just going to simplify. This is negative square root of 1 over the square root of 50, which is negative 1 over 5 radical 2. And then multiplying by radical 2 in the top and the bottom, we get negative radical 2 over 10. For the second problem, it's much easier since we now know the value of cosine of theta. So to find sine of theta over 2, we are going to use the identity for that, which is here. So cosine of theta, as we know, is negative 24 over 25. We just have to choose the positive or the negative. So let's remember that theta over 2 is in the second quadrant. We talked about that in the last problem. And sine in the second quadrant is positive. So this is going to equal positive square root of 1 minus cosine of theta, which is negative 24 over 25, all divided by 2. This is going to be the square root of 25 over 25 plus 24 over 25, all divided by 2. And this is the square root of 49 over 25, again, all divided by 2, which is the square root of 49 over 25 times 1/2. And that is the square root of 49 over 50, which can be separated. And the square root of 49 is 7, and the square root of 50 is 5 radical 2. And then multiplying by radical 2 in the top and the bottom gives us 7 radical 2 over 10. For the third problem, sine of 2 theta has an identity, and it is 2 times the sine of theta times the cosine of theta. This is a double angle identity. And all we have to do here is fill in the values of sine of theta and cosine of theta. And we know these values. Sine of theta was given to be negative 7 over 25, and cosine of theta we found to be negative 24 over 25. And so all that is left to do here is to multiply. 2 times 7 is 14, and 14 times 24 is 336, and this is going to be positive because negative times negative is positive, and 25 times 25 is 625. And so our answer here for the sine of 2 theta is 336 over 625. For the fourth problem, we are finding the cosine of 2 theta. Cosine of 2 theta has 3 identities. The first one is cosine squared theta minus sine squared theta. The second one is 2 cosine squared of theta minus 1. And the last one is 1 minus 2 sine squared of theta. And you can use any of these, and you'll get the correct answer. I'll just show you what you get when you use the first one. So cosine squared of theta is going to be negative 24 over 25, quantity squared, minus sine squared of theta, that's going to be negative 7 over 25, quantity squared. And now we just have to do the math here. So when you square 24, you get 576. When you square 25, you get 625. Need to be careful here. These negatives do not cancel. This negative stays. And when you square negative 7, you get positive 49. And then, of course, over 625. And now we just need to subtract 576. Take away 49 is 527 over 625. Now to find the tangent of 2 theta, there's 2 ways you can do this. One way to do it would be to use the identity, which is 2 times tangent of theta. divided by 1 minus tangent squared of theta. But to do this, you would need to know the value of tangent, okay? And we could figure that out, but we can also say that tangent of 2 theta is simply sine of 2 theta divided by cosine of 2 theta. And we know that sine of 2 theta is 336 over 625 divided by cosine of 2 theta is 527 over 625. And when we invert and multiply by that fraction in the denominator there, the 625 cancels out, and we end up with 336 divided by 527. All right, on to the next bunch. For the next group of problems, we are solving the following equations, where x is an angle between 0 and 360 degrees. So in the first problem, we have a quadratic type of equation, 2 sine squared of x minus sine of x minus 1 is equal to 0. And I just want to point out that if you were to let the variable u be equal to sine of x, this equation would transform into 2u squared minus u minus 1 is equal to 0. And we would be able to solve this equation by factoring. And this is how that factors. And then you would simply set each one of these factors equal to 0. And here we would get u equals -1/2, and here we would get u equals 1. But we need to remember that we didn't start with u. We started with sine of x, and I made a substitution here so that we would get an equation that is familiar to us. So now I'm going to put sine of x back in for u. So this is sine of x is equal to -1/2, and sine of x is equal to 1. And for these, we just need to figure out where is sine equal to these values. Well, we know that sine is 1 when your angle is 90 degrees. This one we should have memorized, and that is the only angle between 0 and 360 for which sine is equal to 1. Now, where is sine -1/2? For that, I'm going to draw a picture. We know that sine is negative in the third quadrant and also in the fourth quadrant. And if it's -1/2, the triangle would look like this. And this side here would be negative radical 3 and positive radical 3, respectively. And then that means that this angle here would be 30 degrees. So with a 30-degree reference angle, we know that this angle would be 210 degrees, and this angle would be 330 degrees. So the solutions here are going to be 210 degrees and 330 degrees. And so in total, we get 3 solutions. For the next problem, you need to be very careful because it looks a lot like the previous problem, but I want you to notice that the trig functions here do not match. So we cannot factor this like we did in the last problem. First, what we need to do is recall that cosine squared of x is the same as 1 minus sine squared of x. This is our basic Pythagorean identity. So I'm going to substitute 1 minus sine squared in for cosine squared. And when I do that, it looks like this. And now we have only the function sine involved in this equation. So let's go ahead and simplify by multiplying this out. So this is going to give us 2 minus 2 sine squared minus sine x minus 1 equals 0. Combining 2 and -1 gives us positive 1. So we have -2 sine squared x, negative sine of x, and positive 1 equals 0. Now, I really don't like to have a negative in front here, so I'm going to multiply both sides of this equation by -1 to get rid of that negative. And that's going to give us 2 sine squared of x plus sine of x minus 1 is equal to 0. And now we can factor just as we did in the previous problem. So if I let u equal sine of x, this becomes 2u squared plus u minus 1 equals 0. And that will factor in the following way. And now when I set each one of these factors equal to 0, we end up getting u equals 1/2 and u equals -1. But again, u is sine of x. So this is the same as sine of x equals 1/2 and sine of x equals -1. Now for -1, we know that sine equals -1 when the angle is 270 degrees. And again, this should be memorized. And then sine equals positive 1/2, we can figure this out by drawing a triangle in the first and second quadrants, because that is where sine is positive. And sine is opposite over hypotenuse, which means the missing side here is going to be radical 3, which also means that the reference angle is 30 degrees. Same thing for the triangle in the second quadrant. And so the angles for which sine is equal to 1/2 is 30 degrees and 150 degrees. And so the solutions here are 30 and 150. And so again, in total, we have 3 solutions. And for the next problem, it's a little bit different. We have sine of x minus 2 is equal to cosecant of x. So the problem here is, once again, we have 2 different trigonometric functions, kind of like what we had in number 7 here. But we need to remember that cosecant of x is the same as 1 over sine of x. So we can simply change this equation by replacing cosecant with 1 over sine. And now you can see we only have the trig function sine involved in this problem, and that's good. Now the second thing I'm going to do is multiply both sides of the equation by sine of x to get rid of the denominator here. So these are going to cancel out, and on the right-hand side we just have 1. And then on the left-hand side, sine of x times sine of x is sine squared of x, and sine of x times -2 is -2 sine of x. And then from here, I'm going to subtract 1 from both sides to give us sine squared x minus 2 sine of x minus 1 is equal to 0. And now we have a quadratic equation. So once again, I'm going to let u equal sine of x. This is going to be u squared minus 2u minus 1 is equal to 0. And I will point out right away that this is not factorable. So we are not going to be able to solve this the same way that we solved the last 2 problems. Instead, what I need to do here is apply the quadratic formula. So the quadratic formula tells us that u is going to be -2 plus or minus the square root of -2 squared minus 4 times 1 times -1, all divided by 2 times 1. So of course I'm using the quadratic formula, recognizing that we have a 1 here. And so this of course is the value of a, -2 here is the value of b, and -1 here is the value of c, and u is equal to the quadratic formula, which is this, okay? And so all I'm doing is taking those values of a, b, and c and plugging them in. Okay, so in the next step here, -2 is 2. Then we have the square root of -2 squared is 4. And then -4 times 1 times -1 is positive 4. 2 times 1 is 2. So this is 2 plus or minus the square root of 8 divided by 2. And you can simplify this. You can say this is 2 plus or minus 2 radical 2 divided by 2. And if you divide each one of these by 2, you end up getting 1 plus or minus radical 2. And so we have u is either equal to 1 plus radical 2 or u is equal to 1 minus radical 2. Now let's remember that u is really sine of x. So this means that sine of x has to be 1 plus radical 2 or sine of x has to be 1 minus radical 2. And to finish this now, I'm going to use a calculator. So if I plug in 1 plus radical 2 into a calculator, what I'm going to get is 2.4142. And this is not possible because sine cannot be a value larger than 1. For the other one, we have sine of x is equal to 1 minus radical 2. And if you plug that into a calculator, you will see that this means sine of x will be negative 0.4142. Now this is possible because this is a value between 1 and negative 1. And so now we just have to ask, where does this occur? Well, we know that sine is negative in the third quadrant and in the fourth quadrant. But the angles are not special angles because 0.4142 is not a special value. So what we need to do is find the reference angle, which I'm going to call x hat. And we know that sine of the reference angle is going to be positive 0.4142. And so the reference angle is simply the inverse sine of 0.4142. And now all we have to do is plug that into a calculator. And when we do, we end up getting approximately 24.5 degrees. So that's what this angle is right here and right here. And so our solution is going to be this angle, which is 180 plus 24.5, which is 204.5 degrees. Or the other angle is going to be this angle over here, which you can find by doing 360 degrees minus 24.5. And that is 335.5. And those are our two solutions. So as we continue with problem number 9, we are also solving an equation where x is an angle between 0 and 360. This time we have sine of 2x is equal to radical 3 times sine of x. So the problem here is that when you're solving a trig equation, it's really difficult to solve if the angles in the trig functions do not agree. So to remedy this, I'm going to remember that sine of 2x has a double angle identity 2 sine of x cosine of x, and that is equal to radical 3 sine of x. Now the next thing to do here is maybe a little bit counterintuitive, but I'm going to subtract radical 3 sine of x from both sides. This is going to set this whole equation equal to 0. And on the left-hand side, we have 2 sine of x cosine of x minus radical 3 sine of x is equal to 0. Now, what this allows me to do here is factor out the common factor, which is sine of x. So if I factor that out, what I have left over is 2 cosine of x minus radical 3 equals 0. And this allows us to separate the sine function from the cosine function. So now I'm simply going to set each one of these factors equal to 0. So we have sine of x equals 0. Now we know that this happens at 0 degrees and also at 180 degrees. And if we're including 360, we would also have a solution at 360 degrees. So there would be 3 solutions here. And I should just point out that 0 and 360 are essentially the same solution. Sometimes when you get these problems, the 360 will be included, and sometimes it will not be included because, again, 0 and 360 are essentially the same angle. Now, for the other equation here, we're simply going to solve for cosine. So we get cosine of x is equal to radical 3 divided by 2. And then we need to think about where this happens. This is going to happen in the first quadrant and also in the fourth quadrant. And cosine is adjacent over hypotenuse, which means the opposite side here is going to be 1, which means the reference angle is 30 degrees. And so the two solutions here are going to be 30 degrees and 330 degrees, right? Because our solutions are this angle here and then this angle here. For the next problem, we have tangent squared of x is equal to 3. If we take the square root of both sides, we get tangent of x is equal to plus or minus the square root of 3. And so we just need to figure out where is tangent positive radical 3 and where is tangent negative radical 3. And so this is going to happen in all four quadrants. So in the first quadrant, if tangent is radical 3, that means it's going to be radical 3 over 1, like this. The hypotenuse would be 2, and the angle here would be 60 degrees. Tangent is also positive in the third quadrant. That would just be negative radical 3 over negative 1. Hypotenuse is again 2, and the angle here is 60 degrees. And so the two solutions where tangent is positive radical 3 is going to be 60 degrees and 240 degrees. Where is tangent negative radical 3? Well, that's going to happen in the second quadrant and in the fourth quadrant. And it's going to look very similar. In the second quadrant, it will be radical 3 over negative 1, which once again will have a hypotenuse equal to 2 and a reference angle of 60 degrees. And in the fourth quadrant, it's the same story. And so the two angles here are going to be 120 degrees. And in the fourth quadrant, this angle is going to be 300 degrees. So we have four solutions. And in number 11 here, we have cosine of 3x is equal to 1/2. What I like to do here is substitute something for 3x. Let's let theta be equal to 3x. And then that transforms this problem into a more simple problem. Cosine of theta is equal to 1/2. So then what we'll do is we'll find all the solutions for theta, and then we'll find the corresponding solutions for x. So where is cosine positive 1/2? That's going to happen in the first quadrant and in the fourth quadrant. And the corresponding angle here is going to be 60 degrees, and the corresponding angle here is also 60 degrees. And so theta can either be equal to 60 degrees or theta could be equal to 300 degrees. But the way we got to approach this is we need to find all solutions first. So when I say theta equals 60, let's remember that if we add a full revolution to this, that would also be a solution. So I'm going to add 360 degrees multiplied by k. And I'm going to do the same thing for the other angle as well. Okay? So then what I have, if I just remember that theta is really 3x, is I'm just going to put 3x in here for theta. So when we do that, we're going to have 3x equals 60 plus 360k, or 3x equals 300 plus 360k. And then to solve for x, I'm just going to divide both sides by 3 in both of these equations. And this is going to give us x is equal to 20 degrees plus 120 degrees times k. And over here we get 100 degrees plus 120 degrees times k. So I'm just dividing each one of these by 3. Now, these would be our solutions if we wanted all solutions, but we only want the solutions between 0 and 360. So now we need to remember that k is an integer. And so that means that k can equal values like -2, -1, 0, 1, 2, 3, etc. So once you get to this point, the way you find your solutions is just let k be equal to 0, 1, 2, 3, etc. So if I let k equal 0 here, we're going to get x equals 20 degrees. If k equals 1, we get x equals 20 plus 120, which is 140. And if I let k equal 2, we get 20 plus 240, which is 260. And then notice if I let k equal 3, we're going to get 20 plus 360, which is 380. But this is bigger than 360, so we're going to throw away this solution. So our only solutions here are going to be 20, 140, and 260. And then we do the same thing for the other solutions. So if k equals 0, we get x equals 100. If k equals 1, we get 220. And if k equals 2, we get 340. And those are our 3 solutions for that one. And so in total, we have 6 solutions. In the next problem, we have some parametric equations, and we want to get an equivalent rectangular equation. So in problem 12, we have x equals 3 plus sine of t, and y equals -2 plus cosine of t. The way to do this is to simply solve for sine and cosine in each of these equations. So if we subtract 3 here, we get x minus 3 is equal to sine of t. And if we add 2 on the other one, we get y plus 2 equals cosine of t. Now, we know that sine squared of t plus cosine squared of t is always equal to 1. So all I have to do is take x minus 3 and substitute that for sine, and y plus 2 and substitute that for cosine. And if I do that, I get x minus 3 squared plus y plus 2 squared is equal to 1. And this is the corresponding rectangular equation. In the next problem, it's essentially the same thing. We have 2 parametric equations involving secant and tangent. So in the first equation, let's go ahead and solve for secant. So I can subtract 2 from both sides. And then we can divide both sides by 3. We could do the same thing for the other equation, adding 4 to both sides, and then dividing by 5. And what do we know about secant and tangent? Well, we have an identity that says secant squared of t minus tangent squared of t is equal to 1. And so all I need to do here is substitute x minus 2 over 3 for secant and y plus 4 divided by 5 for tangent. And if we do that, we end up with x minus 2 over 3 quantity squared minus y plus 4 over 5 quantity squared is equal to 1. And you could leave it like this, but usually what we'll do here is we will separate the top and bottom of the fraction, squaring each one, and this is the rectangular equation corresponding to those parametric equations. In problem 14, we are asked to solve triangle ABC. Notice that this triangle is not a right triangle. So let's try to draw a picture here. And your picture doesn't have to be 100% accurate, but I want to notice that angle C is an obtuse angle. It's 93 degrees. Angle A is 34 degrees. And angle B we do not yet know. And then side B is 7.9, which would be this side over here, because side B has to be opposite angle B. So to solve this triangle, we're going to use the law of sines. First, let's find angle B by simply taking 180 and subtracting 34, and 93. And if we do that, we find out angle B is 53 degrees. And I can go ahead and fill that in here, 53 degrees. Now, to find side A or side C, we are simply going to use the law of sines. So let's focus on side A. We know that A divided by the sine of angle A, which is 34 degrees, must be equal to 7.9 divided by the sine of the angle opposite 7.9, which is 53 degrees. Solving for A, we get A equals 7.9 times the sine of 34 degrees divided by the sine of 53 degrees. And all we have to do now is plug that into a calculator. And when we do this calculation, we should find that A is approximately 5.5. Now to find side C, we basically do the same thing here. So we're going to have C divided by the sine of 93 degrees is equal to 7.9 divided by the sine of 53 degrees. And that gives us C equals 7.9 sine of 93 divided by sine of 53. And if we do the calculation there, we get approximately 9.9. So our final solution here is angle B is 53 degrees, side A is approximately 5.5, and side C is approximately 9.9. In the next problem, we are once again solving for the triangle with the given information. So here is a diagram of that triangle. Please make sure that you have all of your sides and angles appropriately labeled and in the appropriate spots. So again, side A should be opposite angle A, right? So that's why the 7.6 is opposite the 46-degree angle here. And side B should be opposite angle B. And that means that this missing side here is side C. Now what we're going to do here is use the fact that we know side A and angle A, and we're going to use that to find angle B. And the reason we start with angle B is because we know the side opposite angle B. So the law of sines tells us that sine of B divided by 5.3 is equal to sine of 46 degrees divided by 7.6. Solving for sine of B, we get sine of B is 5.3 sine of 46 divided by 7.6. And that means that B is equal to the inverse sine of this value. So now we just need to plug this into a calculator. And when we do that, we get approximately 30.1 degrees. Now what you need to remember is that this is the ambiguous case. And when you find a solution for B, you have a second possible solution for B, which I like to call B prime. And B prime will be the supplement of this angle. So that would be 180 minus 30.1 degrees. And if you do that subtraction there, you find out that that's 149.9 degrees. Now the question is this a viable solution? Can this be possible? Now if B prime is 149.9, let's take note of the fact that A is 46. If you add these together, you get an angle that is more than 180, right? You get 195.9. This is not possible because we know that the angles in a triangle have to add up to 180. They cannot be more than 180. So even though this is something you have to consider, in this particular case, this is not a solution. So now we know that angle B must be 30.1 degrees. Now we just need to find angle C. Angle C is going to be 180 minus 30.1 minus 46 degrees. And if you do the math on that, we get 103.9 degrees. And once we know angle C, we can use that to find side C. Side C divided by the sine of angle C is equal to side A divided by the sine of angle A. And so that tells us that side C is 7.6 sine of 103.9 divided by sine of 46. And if we do the math on that, we get approximately 10.3. So our solution here is angle B is 30.1 degrees, angle C is 103.9 degrees, and side C is 10.3. In the next problem, we are once again solving a triangle. In this case, we know two sides and one angle. So here is what this triangle might look like. In this case, we know side, angle, side. So we are going to use the law of cosines to find the missing side first. So we know that c squared is equal to a squared plus b squared minus 2ab cosine of c. And so this says that c squared is equal to 4.9 squared plus 3.7 squared minus 2 times 4.9 times 3.7 times the cosine of 75 degrees. And so let's go ahead and do the calculations. So you can just type all this into a calculator, 4.9 squared plus 3.7 squared minus 2 times 4.9 times 3.7 times the cosine of 75. And when you type all that in, you end up getting c squared is 28.31522, etc. And so c is going to be the square root of that number, and that ends up being approximately 5.3. Now, once I know the missing value here, I can find the angles by just using the law of sines. And I'm always going to start by finding the smallest angle first. So the smallest angle is B, because B has a smaller side opposite it than angle A. So we know that sine of B divided by 3.7 is equal to the sine of C, which is 75 degrees, divided by 5.3. And if we do the math on this, we will end up getting B is equal to the inverse sine of 3.7 sine of 75 divided by 5.3. And now we just need to plug that into a calculator. And when we do that, we should get 42.4 degrees. And then angle A is just going to be 180 minus 75 minus 42.4. And if you do that on a calculator, you end up getting 62.6 degrees. So we have angle B is 42.4 degrees, and angle A is 62.6 degrees. And that's the solution to the triangle. Now for number 17 here, we have a triangle for which we know all three sides. This is a side, side, side situation. When you know side, 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 you are going to find the largest angle using the law of cosines. The largest angle is angle A because it is opposite the largest side. So to find angle A, we are going to use the formula a squared equals b squared plus c squared minus 2bc times the cosine of A. Now what we're going to do is isolate the cosine of A, and I've talked about this before in lesson videos, and so I'm just going to write down what that formula would be. So cosine of A is b squared plus c squared minus a squared divided by 2bc. Now we just have to plug everything in. So cosine of A is going to be 4.3 squared plus 7.2 squared minus 9.6 squared, all divided by 2 times 4.3 times 7.2. And this is a value, so let's go ahead and calculate that value. And I get negative 0.35255, etc. So A is just going to be the inverse cosine of this value. And I should note that this value is already on my calculator, and so I'm not rounding it. I'm just going to go ahead and take the inverse cosine of that answer. And when I do that, I end up getting A is 110.6 degrees. Now, once I have angle A, I can find angle B and angle C using the law of sines. I no longer need to use the law of cosines. Now, when I use the law of sines, I'm always going to find the smallest angle first. The smallest angle in this case is B. So we have sine of B divided by 4.3 is equal to sine of angle A, which is 110.6, divided by 9.6. Solving for B, we are going to get B is the inverse sine of the following. So check my work here. And then we're just going to plug that into a calculator. And when I do that, I end up getting 24.8 degrees. So angle B is 24.8. And now to find angle C, we can simply subtract the first two angles from 180. And if I do that subtraction, I end up getting 44.6 degrees. And that is the solution to this triangle. In problem 18, we are looking for the area of a triangle, and we are given two angles and one side. Anytime you're given two angles and one side, you can always find the third angle by simply subtracting the first two angles from 180. And so if we subtract 34 and 93 from 180, we end up getting B is 53 degrees. Now, there is only one formula that involves all three angles of a triangle and one side. And that area formula is B squared sine A sine C divided by 2 sine of B. And then we just got to plug these in. So that's going to be 7.9 squared sine of 34 degrees, sine of 93 degrees, all divided by 2 sine of 53 degrees. And so this is essentially just a calculator problem. So now you just got to make sure you plug these into a calculator carefully. Make sure you put parentheses in the right place depending on your calculator. And also when you divide by the denominator, you need to think of this as being one whole thing. So on most calculators, you're going to need to put parentheses around that as well. But if we do all that carefully, we should get 21.8. And this would just be square units because they didn't give us any units in this problem. All right, in the next problem, number 19, we are given A is 4.9, B is 3.7, and C is 75 degrees. So we're given two sides and the included angle. And in this case, the area is simply 1/2 A times B times the sine of C. And so that is going to be 1/2 times 4.9 times 3.7 times the sine of 75 degrees. And again, we just need to plug this in carefully. This one's a little bit easier to plug in. But if we plug this in carefully, we should end up getting approximately 8.8. And again, this will be square units. For problem 20, we have three sides of a triangle, and we want to know the area. For this, we are going to use Heron's formula, which tells us that the area is the square root of s times s minus a times s minus b times s minus c, where s is the semi-perimeter, which is a plus b plus c divided by 2. So the first thing you need to do in this is figure out what is that semi-perimeter. So if I add 9.6, 4.3, and 7.2 and divide those by 2, we get 10.55. Now we just need to plug in 10.55 for S in all of these spots, and then A, B, and C into their spots. And if we do that, we get this, and then we just need to plug all of this into a calculator. And if you do that correctly, you should get approximately 14.486. And I'm going to round that to 14.5 square units. Now let's talk about complex numbers. So in the first problem here, number 21, we are asked to find each of the following and to give our answers in standard form. So what we're doing here is we are multiplying two complex numbers, both in trigonometric form. To multiply two complex numbers, all we have to do is multiply the moduli. So 3 times 4 is 12. And then for the angles, we just need to add these together. And so 60 plus 210 is 270. And of course, it's the same angle in both spots there. Now to finish this problem, we simply need to calculate what is the cosine of 270, which we should know is 0. And then the sine of 270 is -1. And so this is just 12 times -I, which is -12i. For problem 22, same situation. We are dividing complex numbers, and we are going to use their trigonometric form to do the division and then transform our answer into standard form. So when you divide complex numbers, you are going to divide the moduli. And so 8 divided by 2 is 4. And then for the angles, we subtract. So 150 take away 210 is -60 degrees. And we get the same thing for sine here. Now, there's a few different ways you could do this. I'm going to remind us that the cosine of -60 is the same as the cosine of 60, because cosine is an even function. And sine of -60 is the same as negative sine of 60. And so this is going to end up being 4 times the cosine of 60, which is 1/2, minus I times the sine of 60, which is radical 3 over 2. And then if I just multiply this out, 4 times 1/2 is 2. And 4 times radical 3 over 2 is 2 radical 3. So we're going to have minus 2i radical 3. For the next problem, we are going to use de Moivre's theorem to figure this out. So we have 1 plus I to the 6th power. First thing we need to do is change 1 plus I into trigonometric form. So 1 plus I looks like this. Real part and imaginary part are both 1. That means that the hypotenuse here is radical 2, and the angle, of course, is 45 degrees. So in trigonometric form, this is going to be the square root of 2 times the cosine of 45 plus I sine of 45. And now we have 1 plus I raised to the 6th power, which is the same thing as this complex number in trigonometric form, raised to the 6th power. And we know that to do this, we are going to raise radical 2 to the 6th power, and then with the angle, we multiply that by this number. So it's going to be cosine of 6 times 45 degrees plus I sine of 6 times 45 degrees. Radical 2 to the 6th power is 8. And then 6 times 45 degrees is 270. And again, we know the cosine of 270 is 0, and the sine of 270 is -1. And so when you multiply this out, you should end up with -8i. For problem 24, we are looking for the fourth roots of -16. First thing we need to do is write -16, which is this complex number, in trigonometric form. So we should see that r is equal to 16 and theta is equal to 180. So -16 in trigonometric form is 16 cosine of 180 plus I sine of 180. Now to find the fourth roots, there are 4 of them. What you need to do is find the r value for your fourth roots, and that is just going to be the fourth root of the r value that you started with. So that is the fourth root of 16, which is equal to 2. And then for your angle, you take your original angle, which is 180, and you divide it by 4, which is 45 degrees. And then the spacing between the roots is going to be 360 degrees divided by 4, which is 90 degrees. Now, once you gather all this information, your roots are simply going to be this r value multiplied by the cosine of this theta value. Okay, so that's your first root. And then for each subsequent root, you are just going to add 90 to your original angle. So 45 plus 90 is 135. And then if we add 90 again, 135 plus 90 is 225. And if we add 90 again, we get 315. So those are all the roots in trigonometric form, but we're going to answer in standard form. So to finish this, we need to remember that cosine of 45 is radical 2 over 2. Sine of 45 is also radical 2 over 2. And if we distribute here, we end up getting radical 2 plus I radical 2. And we do the same thing for all of these. So cosine of 135, sine of 135, so we end up with this. For the next one, cosine of 225 and sine of 225 is going to leave us with this answer. And finally, cosine of 315. And sine of 315 is negative radical 2 over 2. So we're going to end up with this answer. And so these are all the roots of -16, the fourth roots of -16. And in our final problem, we wish to convert the following equation to polar form. So we need to remind ourselves that x squared plus y squared is equal to r squared. And we need to know that x is equal to r cosine theta and y is equal to r sine of theta. So we can make a direct substitution here. X squared plus y squared is r squared. Then we have 8 times y. Y is r sine of theta minus 4 times x. X is r cosine of theta. And so we end up with this equation. And then as long as r is not 0, you could divide both sides by r. And if you divide both sides by r, you end up getting this equation. And so that is the polar form of this rectangular equation. Happy studying.